Okay, today we're going to talk about the normal distribution. What is a normal distribution? A normal distribution is a distribution that looks like that. And sometimes it's referred to as the bell curve. Now, a lot of things in nature occur naturally, are normally distributed. The height of people. If you take a group of 1,000 people, graph all their heights, their normal distribution will, the distribution of the heights would look like this. A lot of people are going to be centered at the same height. And as you get taller, it slacks off. Fewer and fewer people are taller. And as you get shorter, fewer and fewer people are shorter. Test grades, normally distributed. The number of chirps a cricket makes is normally distributed. So many things occur in nature are normally distributed. Every distribution has a mean, which is the average. That is going to be called mu. Looks like a little U with tails on it. And let's say we have a test scores, and the mean of this test is a 78. The mean on a normal distribution is going to be dead center here, so that would be 78. And now we're going to talk about something that we've probably never heard of, which that's a sigma. And that would be the standard deviation. Not sure if you ever heard of that before or not, but I'll say the standard deviation for this test was a 3. Now, what a standard deviation means is this is broken into groups, and this is one standard deviation above the mean. So if we add 3 to 78, that would be a score of 81. If we subtract 3 from 78, that would be a score of 75. So this is one standard deviation above the mean and one standard deviation below the mean. As it turns out, 68.2% of the population will be one standard deviation within one standard deviation above and below the mean. Or that would be 34.1 above the mean and 34.1 one standard deviation below the mean. And let's just draw another normal distribution that's not quite normal looking, but you know what I'm trying to do here. And let's go 2 standard deviations above the mean. So if I would add 3 more to this 81, that would become 84. There's my 1 standard deviation, 2 standard deviations. And if I would subtract 3 more from the 75, that is a 72 with a mean of 78. So now I'm at 2 standard deviations above or below the mean, right here and here. And that contains 95.4% of the population. These numbers are important. So you need to memorize 1 standard deviation is 68.2%, 2 standard deviation is 95.4%. And we'll go out 1 more standard deviation. So here's my mean of 78. 1, 2, 3. 1, 2, 3. So 3 standard deviations above the mean. We've got our 84. We're going to add 3 more to that. So we're out here at 87. And we're going to subtract 3 more from the 72, or we have a score of 69. Now we have 3 standard deviations above or below the mean, and that's actually going to contain 99.7% of our population, or almost the entire population. All right, so this is all new to you, I think, and we're going to now talk about something called a Z-score. or sometimes referred to as a standardized score. And you'll see why we need this. But a z-score is calculated as x minus mu divided by sigma. So what is x? X is called a raw score. Mu, of course, is our mean. And sigma will be our standard deviation. Right. So let's say we have a score. Oops. Oh, that's not the eraser. Hold on here. Let's move this up. Come on. So let's find the z-score for a test grade of an 82. All right, well, quite simply, z is equal to x, my raw score, 82, minus my mean, which was 78, divided by my standard deviation, which was 3. Well, that's going to give me 82 minus 78, or 4. 4 divided by 3, that's going to give me a 1.33. Okay, always round z-scores to 2 decimal places. Right. Now, what the heck does that tell me? Well, what that tells me is if my score of an 82 is greater than an 81 at 1 standard deviation, but less than 84 at 2 standard deviations, I'm right here at 1.33, come on, standard deviations above the mean. All right. So in general, basically, a z-score is simply standard deviations away from the mean. Running out of room. So that's all a z-score is how many standard deviations you are away from the mean. And it will give you direction also. So let's find the z-score for a test grade of, let's say, 72. So my z is going to equal my raw score minus my mean divided by standard deviation. 72 minus 78, that's going to be a minus 6 divided by 3, which equals, negative 2. So that would be 2 standard deviations below the mean, and right here is 2 standard deviations below the mean, and there is my score of 72. So notice it gives me a negative, which means I am below the mean. So it gives you direction, either below or above the mean if it's positive or negative, and how far away it is from the mean. Now, why is this important? Well, it's important because I can compare different normal distributions and decide who is comparatively better or worse depending upon how many z-scores I'm above or below the mean. So that's why we call this a standardized score or a z-score. Z-score is just your standard deviations, and it's a standardized score. It allows us to take any normal distribution and compare them relatively to one another. Now, I'll give you an example of exactly what I'm talking about. Okay, so what we're going to do is we're going to compare two different tests, and actually we can compare any two normal distributions. It could be heights and a test. It doesn't matter as long as what we're going to be doing is finding z-scores, and when we find the z-scores, we're going to standardize the distribution. So what we're going to talk about after today is not just a normal distribution, but we're going to talk about a standardized normal distribution. That's not important just yet. We just want to compare using z-scores. Z-scores are your standard deviations away from the means. So the first test we had a mu of 78 and a standard deviation of 3. We took a second test. It had a mean of an 85 and a standard deviation of 2. Okay, you scored an 80 on both tests. Which test did you do better on? And of course, that's relative to the rest of the class. And the way we're going to do that is we're simply going to find a z-score for test 1. Remember, the z-score is the raw score, that's an 80, minus your mean of 78 divided by the standard deviation. Well, that's not a 2, that's a 3. Well, let's just erase that. That looks horrible. Divided by, of course, your standard deviation. Now, 80 minus 78, that's a 2, divided by 3. 2/3 is 0.6666. All z-scores get rounded properly to 2 decimal places. So we've got a z-score of a positive 0.76. That means I am 2/3 of a 1 standard deviation, 0.67 standard deviations above the mean. The z-score over here is going to be calculated exactly the same way. The raw score was an 80 minus the mean of an 85 divided by 2. Well, 80 minus 85 is negative 5 divided by 2, or that's a negative 2.5. So I am below the mean by 2.5 standard deviations. That's actually quite far below the mean. So we did much worse on this test than we did on this. So you did much better on test 1 than you did on test 2, relatively speaking to the rest of the class. You scored an 80 on both. You might be happy with that, but you really shouldn't be happy with this 80 because everybody else, just about everybody else, scored better than you. All right, that's all we're going to do for today. If you have any questions, please on Google Classroom ask me. I'll try and clarify them. I know this might be a little confusing. It's the first time you've probably seen anything like this, but it's actually pretty straightforward and easy. Ask your questions and I'll help you out.